I'm going to show you how you can factor trinomials when a does not equal 1. And there are different ways that you can do this. I'm just going to still use that big X method in this video. But there are other ways that this can be done. Whoops. Including, my markers went everywhere. Including just guess and check. Okay, so factoring trinomials. All right. So again, we are talking about trinomials, which would be ax squared plus bx plus c. So we're going to factor those down, but this time we have a number in front of the 3x squared. But again, we're still going to use that big X, or the X games, I think is what Delta Math calls it. All right, so here we go with example 1. All right, so let's say that we had 2c squared plus 5c plus 3. All right, so a little change when we do the x. All right, so we're going to come over here, and this top is still going to be what it multiplies to be, and the bottom is still going to be what we need it to add up to be, but it's going to be done differently. If we have a leading coefficient, then we need to multiply these to get this top number, and then this is what we need to add up to. So we're going to multiply those together. So we want to figure out numbers that multiply to be 6, and I'm getting 6 from these two, multiply to be 6, but adds up to be 5. So think about it. What will multiply to be 6 that adds up to 5? All right, hopefully you're thinking 2 and 3, because those multiply to be 6, add up to 5. But there's one additional step, and that is, since I borrowed this 2 to get the multiplication up here, I now need to divide it back out. Okay, so this number right here was multiplied to get this 6, but now I need to divide it back out down here. So this one is going to stay 3 over 2. This one, we can simplify that down to be 1. So now I'm going to take those two numbers, but here's where it's a little different also. If we just get a whole number, like 1, or an integer, we'll say, because it could be negative. So if we just get a number, then that is going to be just like it was on a trinomial that didn't have a leading coefficient. If we get a fraction, what's going to happen is that denominator becomes the coefficient, and then the plus 3 is at the end. All right, so the reason why this works is because we need to get numbers that multiply to get 3, which is why we have to divide it back out. But we have to keep in mind that if we were to distribute this back together, remember that's our way of checking, if we multiply that together, we get 2c squared. If we didn't have that 2 right there, we would only get c squared. All right? When we multiply those together, we get 3, which is what we're supposed to have, even though over here we were pretending we needed 6. But then the middle, which would be 3c and 2c, that will give us the 5c. All right, so the steps are a little bit different, still using the same idea, still making the big X, trying to figure out what multiplies to be this number that adds up to that number. It's just that we need to borrow that coefficient right there to get this, but then we have to divide it back out before we write our answer. All right, let's try another one. For example 2, okay, let's say we have 15n squared plus n minus 2. All right, sorry, I'm crooked here. Okay, so we're going to go over here and make our big X. All right, so we need to multiply and get negative 30. So I'm looking for numbers that will multiply to be negative 30 that will add up to be 1. Okay, so I need numbers that multiply to be negative 30, which I'm getting from right here. So I need to multiply by negative 30 but add up to a positive 1. So give you a minute to think about those. Multiply to be negative 30, but add up to 1. Hopefully you're thinking of 6 and negative 5. Okay, but again, I need to now back that 15 back out. So I need to divide both of those by 15. Now, I don't want decimals. I want fractions. That's fine. So this one I can reduce by 5. So that would be negative 1 over 3. This one, I can divide both of those by 3, which would make this 2 and this 5. So now I'm going to use those two. Now, the way it works is the denominator becomes the coefficient. So this 5 is going to attach itself to the n, and then it's a plus 2. For this one, the 3 is going to attach to the end, and then it will be a minus 1. So the way we can check is by multiplying it back together. So this gives us 15n squared, which is what we needed. This right here gives us negative 2, which is what we needed. And then if we do that, would give us a negative 5n. If we multiplied right there, we would get a 6n, and that becomes a positive 1n. So again, very similar to what we were doing when the leading coefficient was a 1. This time, our coefficient is going to be something else. So we're going to borrow it when we multiply, but then back it back out before we come back over to our answer. All right, here's another one. So example 3. Okay, let's say we have 4x squared plus 15x plus 9. All right, so I'm going to go over here and do the big X. So I'm looking for numbers that multiply to be 36. Okay, multiply to be 36, but add up to 15. So I get 36 right here. So multiply to be 36, but add up to 15. So I'll give you a minute to think. Multiply to be 36, add up to 15. Hopefully you're thinking of 12 and 3. But now I need to divide that 4 back out, because I borrowed the 4 over here, but now we have to bring it back out before we can come back for our answers. Okay, this one, oh, I didn't mean to circle that. Pretend I didn't. Okay, that one equals 3, so that one's done. So I know one of the answers is going to be x plus 3. This one doesn't reduce, but I know that the 4 is going to come to the front. So 4x plus 3 is going to be how we write this one. And then again, you can check 4x squared. We get a 9 there. That would be 3x and 12x, which would give us the 15x. All right, one more, and I'm going to try and give you a little more thinking time on this one. All right, so let's say that we have, how about 6n squared minus 25n plus 14. Ooh, that one might be too hard. Let's think. This one might be too hard. Okay, let's see what happens. So we need to multiply and get 84, but add up to negative 25. So multiply to get 84, but add up to be negative 25. So whenever you have something like this, one thing that I notice, 84, I know I can definitely divide by 4. So 84 divided by 4 would be 21, which gives me the 25. All right, so in order to get a positive 84 but a negative 25, I need a negative 4 and a negative 21. But we need to divide the 6 back out. Okay, this one can be reduced. So we can reduce both of those by 2. So that would be negative 2 over 3. And then this can be reduced. Both of those can be divided by 3, which would give me negative 7 and 2. So to write the answer, this one, the denominator goes out front as the coefficient. So this one will be 3n minus 2. And then this one is going to become 2n minus 7. And then, again, a way to check is multiplying back together would give the 6n squared right there. This would give us the 14. And then if we distributed that, we would get negative 21n. If we distribute that, we'll get negative 4n, which gives us the negative 25n. All right, so again, if you need to go back and re-watch the video to just confirm the steps, but we need to multiply those two together to get the number that we're looking for to multiply, and then use the middle to get the sum, but then we need to remember to divide the leading coefficient back out before we write our answer.